Welcome back everyone. Today I'll be doing the inverse Laplace transform of the following function. Now I'm going to find the inverse Laplace transform of this function. I will be transforming it from a function of s to a function of t. In order to do this, I have to express this as a partial fraction. So the denominator helps to tell me which type of partial fraction I need to use. So I'll have a over the first bracket s plus 1, where a represents a constant, plus, because this is s squared plus 4 and it cannot be factorized, this is a special case where I will have the variable s in the numerator. So I will have capital B and then s, where s is the variable, b represents a number, plus c. So whenever you can't factorize the quadratic, you have to put it in this form. Now let's find the LCM of this. So drawing my line, and the LCM for s plus 1 and s squared plus 4, it will be s plus 1 times the s squared plus 4. So that will be my LCM. Just like how you find the LCM for a fraction. Then I am going to see the s plus 1 that I have here into the denominator here. The s plus 1 cancel and I'll be left with s squared plus 4. So a times s squared plus 4 I'm not going to expand this. So I'll leave it as x squared plus 4 times a, plus s squared plus 4 into the denominator. The s squared plus 4 cancels, so I'll be having s plus 1 times my numerator. So I will have capital B, which is a number, s, plus c times s squared plus 4. Now what this is really saying is that it's equal to the left hand side. So this will assist me to find what is A, what is B, and what is C. So the left is the same as the right, and the denominators are the same, just the numerator I'll be focusing on. So it means that since the denominators are the same, exactly the same as you can see, then I can find out what is A, B, and C. So we equate the numerators to be equal. Now, having this, I like to look at what can I eliminate. And here, if I put s to be -1, all of this will be gone. So I can substitute s to be -1, and this will assist me in finding one of the letters. In this case, I'll be finding A. So replacing s to be -1. So I have 4 times -1 square minus 5 times -1 plus 6. And over this side, replacing -1 here, this will become 0, and 0 times the next bracket will be gone. So there is no need for me to work this part out. And that's what I want. I just want to be left with one portion. So replace s to be -1 right here. I am going to have -1 square plus 4. Now, -1 squared is +1, and 1 plus 4 is 5. So I'll have 5a on my right hand side, and then on the left hand side, -1 squared is 1. So 1 times 4 is 4. -1 times -5, that's +5 plus 6. So adding 4 plus 5 plus 6, that gives me 15. Now I have 15 equal 5a, so I divide both sides by 5, and this cancels. 5 into 15 goes 3 times, so a is equal to 3. I am going to find b and c, but using a different method from substitution. So looking at the numerator, still having it been equated to be equal, I still need that information. You could have substitute 0 into this. Now thinking about it, you could have substitute s equals 0 to get 6 is equal to, some of the s's would be eliminated, and just by looking at it, I'm able to find c. So you can use substitution, it doesn't mean you can't, but I'm not going to do that. I am going to expand this. So a times s squared, that's as squared. A times 4, that's 4a. Then expanding this part, bs times s, that's bs squared. So I have bs squared. Bs times 1, that's bs. And c times s, that's cs. And c times 1, that's c. So I have plus c. So equating it to be equal to my left hand side, and I am going to equate the coefficient of s squared to be equal, then work my way to get the remaining. Now I know that a is 3. So having this information, I am going to equate the coefficient of s squared to be equal on the left and the right. They're going to be equal. So the coefficient of s squared is 4. So it means on the right, a plus b, which is the next coefficient of s squared, whatever they are, they should be equal to 4. Now I know that a is 3. So it means I can find out what is b. Substituting 3 here, just by looking at it, we are seeing the answer. But let's carry this over. So I have b is equal to 4 minus 3. So that means that b is equal to 1. Now I'm going to look at the coefficient of s. So I have negative 5 is equal to, and on my right hand side, I will have b plus c. Those are the coefficient of s. And I know b is 1. So I have minus 5 is equal to 1 plus c. And I carry over the 1 over, so it becomes minus 1. So I have c is equal to negative 6. So that means I have the answer. What is a, b, and c? I'm going to substitute it. Remember what I have here is a over s plus 1 plus b s plus c all over. We're going to have s squared plus 4. Now I know what is the value of a. A is 3, so I substitute it to have 3 over s plus 1. And I also know b and c. So b is 1 and c is minus 6. So I will have, instead of saying 1s, I'm just going to have s minus 6 all over s squared plus 4. So the next step is to find the inverse Laplace transform of each of these by identifying which function I will be using, and that is a function of t when I find the inverse Laplace transform. So it's factoring out the 3, so I have 3 on the outside, and finding the inverse Laplace transform of 1 over s plus 1. And for the next part, where I have s minus 6 over s squared plus 4, I'll be splitting this up. So I will have the inverse Laplace transform of s over s squared plus 4, but 4 is the same thing as 2 squared. So I'm going to write it as 2 squared. And then the minus 6 over s squared plus 4, I put the minus on the outside. 6 all over s squared plus 4. Now 4 is the same thing as 2 squared, so I'm going to have my 2 squared here. So now is to identify which t function to use. Now one of the rules is that when I find the Laplace transform of e to the at, it's 1 over s minus a, and if it is e to the minus at, then it's 1 over s plus a. Now a represents 1 in this case, so it means that I will have 3e to the minus 1t or minus t. The next one, I have a sine and a cos. So I'm going to write sine at, but we're also going to use cos at. So both of them will be used in this case. So let's look at the cos at that I have here. Cos at is equal to s over s squared plus a squared. And that is the Laplace transform. So if I'm moving in the reverse direction, it means I have it here, s over s squared plus 2 squared, where a in this case is 2. So this would be cos 2t. And the next one, sine at is equal to a over s squared plus a squared. And here, I'm not seeing a. In this case, the 2 squared gives me what is a. So I rewrite 6 as 2 times 3, and then I factor out the 3. Based on how the rule is that a should be in the numerator and denominator. So it means I need to factor out the 3 outside. So that means I have 3, and then transforming this based on this information, it will be sine 2t. And here we have found the inverse Laplace transform, where we transform the function of s to a function of t. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, leave a comment below. Have a great day.